Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 29, 2025, just yesterday. This paper demonstrates that reinforcement learning can dramatically improve how autoregressive models, that is, models that generate content step by step, create images. The paper is titled X-Omni, Reinforcement Learning Makes Discrete Autoregressive Image Generative Models Great Again. And as we'll see, the results for rendering text within images are really impressive. The authors present a unified framework that handles both image and language generation, achieving these results without needing classifier-free guidance. Over on Hugging Face, you'll find the 9.6 billion parameter models for English and Chinese, plus a demo space to try out their impressive text rendering capabilities. So right at the start, the authors showcase what X-Omni can do. We see a grid of images here, and they're really striking. The top row shows how well the model follows complex instructions, like generating a hyper-realistic bird or a bulldog in diving goggles. But the really impressive part is the next two rows, which show its ability to render text. We see clear, well-integrated English text on posters and flyers, and then the model does the same for Chinese characters. This really highlights the power of their unified autoregressive framework. So this next figure shows exactly how they achieve that quality jump. The key is reinforcement learning, which is like giving the model rewards for creating better images. The chart on the top right shows the reward score during this RL training. It quickly surpasses the performance of the initial model, which was only trained with supervised fine-tuning, or SFT. The RL model even beats the best of 16 samples from that initial SFT model. And the images below really drive this home. You can see the outputs getting progressively better and more accurate. Alright, so this figure shows the architecture that makes all this possible. At the very center, you have the unified autoregressive model. This is the component that reinforcement learning trains to get better. On the input side, it takes in text through a normal text tokenizer. For images, it uses a component called SIG-LIPVQ, which is a semantic image tokenizer. It essentially converts an image into discrete tokens that capture its meaning. The autoregressive model then outputs a sequence of these tokens, which are fed into a diffusion decoder, a powerful tool that reconstructs the final, high-quality image. Moving to the results, this table quantifies the performance of that architecture, focusing on its text rendering capabilities. The models are tested on two benchmarks, one IG bench and a new, more challenging long text bench, for both English and Chinese. These benchmarks measure accuracy using things like edit distance and word completion. As you can see, X-Omni achieves state-of-the-art results, outperforming other unified models like GPT-4o on the 1IG bench. And on the long text bench, it really shines, especially for Chinese, where it beats every other model by a large margin. Building on its strong text rendering, this next table looks at general text-to-image generation. The models are evaluated on DPG bench, which is designed to test how well they can follow complex instructions. The benchmark breaks performance down into categories like correctly generating entities, their attributes, and the relationships between them. And if you look at the overall score on the far right, X-Omni comes out on top, achieving a state-of-the-art score of 87.65. This result demonstrates that the benefits of reinforcement learning improve the model's general instruction following capabilities. Now, while the main improvements are in generation, it's important to see if that comes at a cost to understanding. This table answers that question. It compares X-Omni against other models on a suite of image understanding benchmarks. We can see that X-Omni achieves results comparable to other top unified models like Show-O2, and it significantly surpasses earlier works. What's especially notable is its performance on OCR Bench, a benchmark for reading text and images. Here, it scores a 704, which really complements its strong text rendering ability. So to wrap things up, X-Omni really demonstrates that reinforcement learning can make discrete autoregressive models great again. It achieves state-of-the-art results in complex text rendering and general instruction following, all while maintaining strong understanding capabilities in one unified model. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.